In this video, I provide information that I hope will help you explain to others how to understand percentile ranks. Percentile ranks, PRs, provide teachers information on a student's relative standing in a group and are best used when the group is 100 or more students. The manner in which they are calculated may help teachers in understanding the definition. Scores are ordered from highest to lowest, and a frequency count is made of the number of scores at each value. Then a decision is made to either separate the frequency count at each score value into all below or above that score value, or half below and half above that score value. This process may help teachers appreciate the definition as the proportion of scores in a distribution in which a specific score is less than it, or less than or equal to it, if that second option is selected. The important point of this definition is that a percentile rank informs teachers where a student is located, ranked in a larger group of students. Percentile ranks are an important metric for teachers to use in evaluating risk. Basically, a percentile rank shows teachers, informs teachers, where a student is located in a larger group. And as you remember in the introduction, this group of students is ranked from high to low. And so percentile ranks help teachers organize these students into equally performing groups. So, for example, a response to intervention system might identify students at the 20th percentile rank or the 25th percentile rank to be targeted for further investigation, diagnosis, or intervention. In most response to intervention systems, the percentile rank is the lowest group for further consideration. Calculation and interpretation of percentile ranks is really quite straightforward. On the left column, you have 10 scores of students. And then in the next column over, these scores have been ranked, in this case, lowest to highest. Now the formula, PR, equals in the column to the right. And it's basically the rank order of the score one is interested in, divided by the number of scores plus 1. This calculation is multiplied by 100. So in this example, we have the response of 21 is the second rank ordered from low to high, and it is divided by 11 because we've got 10 scores, and that equals 11 for the denominator. As we would expect, the second ranked score from the bottom is at the 18th percentile rank. A key piece of this percentile rank interpretation is that we only had a single student, and so it wasn't possible to determine how many scores are at each scale value. Furthermore, if we had more students and it formed a bell-shaped curve like this, we would find we could go across different percentiles, for example, the 10th, 20th, 30th, or the 5th, 10th, 15th, 20th, 25th, 30th. In EasyCBM, you have all sorts of options to summarize percentile ranks in whatever grouping you want. Another important caveat, though, is that these scores are not equal interval. Basically, the spread between two adjacent percentile ranks is not the same in the score values for them. And typically, the difference between two percentile ranks in the middle is far less on the raw score than two of the same percentile rank differences on the extremes for these two raw score values. In other words, it's a lot easier to show change in the middle than in the extremes, where oftentimes we have to gain considerable ground to move a student from the 5th to the 10th percentile rank. A 5 percentile rank gain, which is far more work than going from the 50th to the 55th percentile rank, where it wouldn't take much in score values to see that change. So that's one important caveat, and you can see on the bottom the normal curve equivalence is an equal interval scale, and PRs, or percentile ranks, can be converted to them if teachers want to use them in their growth monitoring. And here's an example of a box plot. It shows you the box itself. The lowest bottom of the box is the 25th, the middle is the 50th, and the top of the box is the 75th percentile rank. The lines that extend above up to the 90th, and the line that extends below is down to the 10th. And this is called a box and whiskers plot, and helps you see the distribution of students in the box, which is where most of the students should be performing. And here's an example that depicts some measure absences from 2009 to 2013, and you can see in 2011, well, it was a very good year. The bottom to the top of the box was fairly narrow, so there weren't a lot of differences among students. The bottom of the box was the highest, and the top of the box was the second highest of all those years. At the same time, you can see that there were some students who were quite a bit above on the 90th and definitely quite a bit below on the 10th percentile rank, indicating very few absences. In the end, percentile ranks should be used to determine whether students are at risk and to identify appropriate materials for progress monitoring, but they shouldn't be used to show growth from fall to winter to spring. Raw score values or normal curve equivalence would be far better to do that. As you can see, a percentile rank is quite different than percent correct, because relative standing in a group depends on how all other people in that group perform. Percentile ranks do not necessarily work the way that people are used to having numbers work. For example, a 1-point gain in a raw score in the fall may translate to a 3-point change in percentile rank on a given measure. That same 1-point gain in raw score in the spring, however, may translate to an 18-point change in percentile rank. Changes in percentile rank depend on how everyone else performs on the thing being measured. As a result, goals should never be set on a specific percentile rank change.